Right. Okay, so I just want to explain that. So we used a formula a moment ago, which is I came up with this version of the formula. I said nx is the amount of times the amount of whatever it is that we're looking at after the x times that it has doubled or halved or whatever it's doing. If it's depending, so we're talking about growth and decay. N0 is the amount that it has. The amount it was at the start. So we wrote this down up here somewhere up there, over here, um, and I just want to show you how it's the same as what they've written here. The R is the amount it will what is the change. So is it going to half? Is it going to double? Is it going to reduce to a third or whatever it might be? And then the x is the amount of times it's going to either half or double or whatever it is. So it's the same. The reason why it's the same as this one, well, the reason why it's slightly different in this case, just because the I represents the interest that's been made. It's usually, this is more like for money. So you would have A is your final amount. So A is like our nx. P is the principal amount. So the starting amount. So that's like our n0. I is the interest rate per year. Now that means in our case we didn't do the difference. We did the amount um, the amount by which it changes in terms of the whole fraction. So let's say that it doubles, the interest would be 100% in that case. The interest would just be 1. So 1 plus 1 is 2. So R is actually 1 plus I if we're going to compare the two. And then n for that case is x. So like I said, if we had it's something that's going to increase by 5%, then I would be 5%. But if we want to apply it to the formula we were learning earlier on, we'll say R would be equal to 1.05 because it's going to be 1 plus 5%. So we need to convert the percent into decimal. So we're probably gonna use this formula from now on if we're doing like a bank, interest on stuff, if it's in percentage. But we do need to be aware of both formulas, because if we're doing questions like this, a sample of bacteria triples after every minute, then the percent formula which I just showed you, it just isn't going to work then. I mean, you could still adapt it. If it triples, then it's increased by 200%. It had the original percent, 100%, plus another 200. So the new percent will be 300%. So it's tripling. But you can see why in that version of question, I use my formula, whereas in these versions of questions, it makes more sense to do that. But they're the same formula. It's just good to know how they both work. Okay.